Hi everyone, this is Mr. M from Algebra Lessons. Today's video I am trying to explain about the method of finding solution of a quadratic equation using factorization technique. So how can we use those methods to find the solution of a quadratic equation? Let me explain that. Okay, for that I'm choosing two different questions. The first one is 2x square minus 12x plus 18 equal to 0, and the second one is let me try with a different color. The second one is 7x square. Okay, 7x square plus 48x minus 7 equal to 0. So we have two different equations. When you are looking into these two equations, probably you may think that, oh, there is no difference, both are quadratic, and both can be solvable by using some methods. But here we are trying to use the method of factorization. So I'm stressing the term factorization because factorization is the technique to split the polynomial or split the statement into pieces. Depends on the degree or the exponent of the statement. We can decide, or we can figure out how many pieces will be there. Because we are dealing with a quadratic equation, as you know that this is an equation of degree 2. That means we will have only two pieces, or the number of solutions will be 2, and the number of solutions will also be depends on the discriminant part of the quadratic equation. I'm actually not spending time to describe about the discriminant part, because you already covered those things in the previous lessons or something like that. So I'm going to start with the first question. It is 2x square minus 12x plus 18 equal to 0. So let me start from this. Okay, so when you're looking into this equation, you can see that all the terms of this equation is divisible by 2. So divided by 2, divided by 2, divided by 2, and divided by 2. Okay, so that means cancelled out. This is 6, and this is 9, and this is 0 itself. Okay, so the remaining part is x square minus 6x plus 9 equal to 0. Plus 9 equal to 0. So in factorization, most of the time we will use the method called sum and product. Okay, so the last term, that means we need to figure out two numbers which will give you the sum, which will give you the product as the constant. So this will be the product. So if a and b are two terms, so a times b will be the last term, and this term will be the sum. So consider two numbers that will give you the product as the constant and the middle term as the sum. So this will be a plus b. So how can you find those two numbers, a and b? So I will use this technique. I will factorize the last term, the constant number, into its small pieces. So what are the factors of 9? 1 9, 3 3, and what else? No, nothing more. That's it. Okay, then go ahead. Now we have a set of numbers which will give the product positive, and be careful about the sign. Okay, here the product is positive, that means both the numbers will be either positive or both the numbers will be either negative, because the product is positive. So to figure out whether both are positive or both are negative, you need to check the sum also. The sum is a plus b is negative 6. Okay, if both are positive, product will be positive. If both are negative, chances are there for the sum will also be negative. Okay, so here this is negative 6. So from these two pairs, figure out which pair will satisfy our condition. So 1 times 9 is positive 9, 3 plus 3 is positive 6, but we need negative 6. Let me try with a different sign. So I'm choosing a negative sign here and here. So negative 3 plus negative 3 is negative 6, and negative 3 times negative 3 is positive 9, because negative times negative creates positive. So don't forget this rule. Okay, so that is the set of numbers will satisfy this condition. So we can rewrite this quadratic as the product of two items or two factors. So because the variable used here is x, write that variable first and check the signs of these numbers. So these both are negative, so that sign you should put there, and the numbers that is equal to 0. So now you have two pieces as the product. So here you have to use the zero product property. That is, if the product of two numbers is equal to 0, means either P equal to 0 or Q equal to 0. This is called the zero product property. And so we can use that here. X minus 3 into x minus 3 equal to 0. That means either the first x minus 3 equal to 0 or the second x minus 3 equal to 0. So x minus 3 equal to 0 means what is x? Add a 3 on both sides. So x will be equal to plus 3. Here also the same, add a plus 3 on both sides. So x will be positive 3. So from this what we can say, that is the solution of this equation 2x square minus 12x plus 18 equal to 0 is x is equal to x is equal to plus 3 or positive 3. Okay. At this point, you can ask a question. Because this is a quadratic, you said depends on the degree. The solution will be equal to the degree of the given expression. So because we considered or we factorized a quadratic, here we have only one solution. But if the quadratic equation discriminant, so if ax square plus bx plus c equal to 0 is a quadratic equation, we can call the part b square minus 4ac as the discriminant. Okay, for this particular equation, if you find the discriminant, you can see that this b square minus 4ac will be equal to 0. That is the reason this equation will have only one solution. Sorry, we have two solutions, but those two solutions are same. So that is the reason behind why this is having the same solution. Okay, so that is the first kind of question. And the second kind of question, exactly the same question I'm going to rewrite here. The second kind of question is this. It is 7x square plus 48x minus 7 equal to 0. Okay, 7x square plus 48x minus 8 is equal to 0. Okay, let me try with a different color. Okay, so like what we did for the previous problem, we cannot divide each number with a common element. So here this is 7, this is 48. There is nothing common in 7 and 48. So what we can do? That is the question. So that is why I said this is a second type of problem. Okay, so in the first problem or the previous problem that I did or I explained, what we did there is we actually divided all the terms of the given expression with a common number to make the coefficient of the second degree term as 1. Here also we can try that, but we found that there is nothing common in between the 7 and 48. So we need to look for another method or another way to solve this problem. How can we do that? We have some easy technique. So I'm going to use one easiest method. That this is also following the sum and product, but we need to set it for using this technique. How can we do that? For that, what you need to do is, first you need to check what is the coefficient of the x square term. The coefficient of x square term is 7. That is not equal to 1. Go ahead and multiply this coefficient, this first coefficient and the constant term. Okay, what is the product of this coefficient and the constant term? 7 times 7 is 49. So 49, this is negative, so negative 49. Keep that number there. And what is the middle number? Middle number is 48. So find two numbers which will give the sum plus 48 and which will give the product negative 49. Interesting. How can we find it? Okay, so what we did in the previous problem is we factorized the constant term. So consider this product as the constant. Okay, so factorize this 49. Which are the factors of 49? We don't need to consider this sign right now, but we will consider later, just after this factorization. So what are the factors of 49? 149 and 7. Yes, those are the two factors of 49. Okay, then which are the conditions we need to consider? Okay, what is the sign of this middle term? The sum. Sum is positive. Okay, sum is positive and the product is negative. Interesting. Sum is positive and the product is negative. When we will have negative answer for a product, it happens only when any one of that number should be negative. Okay, we can consider 1 and 49, 7 and 7. If this is negative, this is negative and this is positive, the sum will be 0. So we cannot consider this thing. So we can eliminate this case. Then what is this case? 1 and 49. Product is negative. That means any one of this should be negative. Then we need to check before we finalizing the sign of any one of that term. We need to check the sum. Sum is positive. So sum is positive means this larger number should be positive. So this is positive and this is negative. Okay, negative 1 plus 49. That means positive 48 and negative 1 times 49 is negative 49. Okay guys, so we have two numbers. One is negative 1, one is negative 1, another one is positive 49. Okay, go ahead. What we are going to do here is we will split this middle term. That is the process behind this. Once you finalize the numbers with its sign, you need to split the middle term. Okay, so we can rewrite this equation 7x square plus, what are the two terms? One is negative 1 and another one is positive 49. So add the variable with this. So you can write 49x and minus 1x. See here 48 is rewritten as 49x minus 1x. You know that 49 minus 1 is 48. So nothing is changed, just split it. Minus 7 equal to 0. So guys, we are actually completed fifth term. So now what you need to do is you can group the first two terms and the last two terms. So 7x square and 49x, what is common there? 7x square and 49. So you can see that here you have 7x times x plus 49 is 7 times 7x. Okay, and from both of these two terms you can take -1 out or negative sign out, negative of, remaining is x, and here it is plus 7 equal to 0. Okay, so in this parenthesis, what is common? Here you have a 7x, here also you have a 7x. Take that as common outside, so this will be 7x times, so this 7x is outside now, x plus 7 minus of x plus 7 equal to 0. Guys, we are in the last stage of the problem. How can we solve it? That's the question. So this will be 7x times x plus 7 minus x plus 7 is equal to 0. And now you have to take the common number or the common term outside. In both of this problem, you can see that, in both of these statements, you can see that x plus 7 is common. Take it out. So this will be x plus 7 times, what is remaining here? So x plus 7 is outside now. So remaining is 7x minus x plus 7 is outside now. Remaining is 1 equal to 0. So I believe you know what I'm meant with taking out. We are actually dividing each term with x plus 7. That's what the real process, even though I'm saying take it out. So x plus 1 and x plus 1 cancelled out. So 1 divided by 1 or 50 divided by 50 or 100 divided by 100 is 1. So that is 1. Okay. And again here we can use the zero product rule. So product of two terms equal to 0 means any one of that should be 0. So either x plus 7 is equal to 0 or 7x minus 1 is equal to 0. So x plus 7 equal to 0 or 7x minus 1 equal to 0. So from this x is equal to -7. That is the first solution. Next one is 7x minus 1 is equal to 0. That is 7x is equal to plus 1. So x is equal to plus 1 over 7. So you have two solutions. One is x is equal to -7 and another one is x is equal to plus 1 over 7. So here you can see that we have two different solutions. From this we can say that we can conclude one property of the discriminant. If b square minus 4ac, if b square minus 4ac is a positive number, then you can say that that quadratic equation will have two different real roots. I'm actually going backward. You guys studied this discriminant instruction in your previous year. That is why I'm not explaining that. But from this answer to that discriminant, if you check the discriminant part of this given quadratic, you can see that that will be a positive number. So that means this quadratic equation will have two different real roots. So in the beginning itself, we can get into a conclusion that yeah, really this equation will have two different real roots. So then you need to figure out what will be the method to find that solutions. Okay, so the very first method you can see or practice is the sum and product using factorization technique. I hope you all already understand the concept from my explanation. If you really wish to get more videos of the same kind, please like, share and subscribe my channel. Thank you very much for watching.